In this video, we're looking at simultaneous equations and using the elimination method to solve them. So before we begin, we'll look at some terminology. So the elimination method is a method of solving simultaneous equations that involves combining them to eliminate one of the variables. Now, a coefficient is the numerical part of an algebraic term. So for example, if we have 7x minus 1, the coefficient of x is 7. So it's just that front number. Now, when you're solving simultaneous equations, if you're using graphs, these can be time consuming and often inaccurate. So the best way to do it is algebraically. Now, there are two methods, the elimination and the substitution. So this video is going to cover the elimination method. Now, this method involves adding or subtracting equations to eliminate one of the variables or the letters or pronumerals, whatever you like to call them. So I'm going to go through a couple of examples. So here we have two equations and we need to solve them simultaneously. So the first thing I think you should do is underline what you want to cancel out. So we're looking at cancelling out the r's here because they're the same. They have the same coefficient. They're both 3r. Now one's a plus and one's a minus. So we either have to add the equations or subtract them. So what I like to do is write them on top first. So we've got 4q plus 3r equals 8. Down here we have minus q minus 3r equals 7. Try to keep the same variables up, below and above each other. So like the q's are next to each other, the r's are above and below, and then the regular term, constants 8 and 7 are together. Now, if I was to add this together, I would get 3r plus minus 3r, which means 3r take away 3r, so that cancels out. Whereas if I tried to subtract them, I'd get 3r take away negative 3r, which means that's a positive. So we'd end up adding them and not cancelling anything out. So in this case, we're going to add the two equations. At this point, I like to draw a line going across. And what you do is you just focus on each part. So I'm going to focus on the q's here. And we go 4q plus minus q, so 4q take away q. And that gets me 3q. Oh, I'll go back to the right color, 3q. Then we have 3r plus minus 3r. So again, I'm looking at this section this time. 3r plus minus 3r. So that's 3r take away 3r. So we get nothing, so I don't have to worry about writing anything. The equal sign stays. Then we get 8 plus 7, so 15. And now we have an equation with just one variable, a q. So now we can solve for q. So how do you get rid of the 3? If you think back to your inverse operations, remember this is 3 times q. So what's the opposite of times? Divide. So we want to divide this. So we'll divide by 3. And what you do to one side, you do to the other side. So we get q equals 15 divided by 3, which is 5. So at this point, we know q is 5. We still need to find what r is. So what we do here is we substitute q equals 5 into an original equation. Alright, so we can pick anyone there. Let's pick the first one, the second one, the minus q minus 3r equals 7. So we have minus 5 now, minus 3r equals 7. Let's plus 5, plus 5. I get minus 3r, 12, and then we divide by negative 3. So r comes out as negative 4. So q equals 5 and r equals negative 4. And that's how you solve, that's an example of a simultaneous equation. So we're going to look at another one now. So again, I'm going to write them above each other. I notice that they're the same, so this time I'm going to try subtracting. Draw my line going across the bottom. 6p take away 4p is 2p. C take away c is nothing. 16 take away 10 is 6. Divide by 2. So p equals 3. So notice that when the signs of the thing we're trying to get rid of, so in this case the c's, when we're trying to get rid of them, if the signs are the same, you subtract. If the signs were different, we add. Now that we've got that, we can go back and substitute into the original. So sub, I won't write the whole thing out, substitute. So let's substitute it into the second one. So we got 4 times 3 plus c equals 10. 12 plus c equals 10. Minus 12 from both sides. Oh, I'll cross those out. And we get c equals negative 2. So p equals 3 and c equals negative 2. One more. Now notice here, we have a problem. If I write 2x plus m equals 5 and 3x plus 2m equals 3, nothing's the same. So when this happens, you need to choose which one and multiply it by some sort of number, constant, to get it to the same. So I'm going to focus on getting rid of the m's. Now what would I need to multiply my equation 1 by to get it to 2m? So I'd need to multiply it by 2. So here I'm going to write equation 1 times 2. So now what I get is 4x plus 2m equals 10. Alright? Now I can go back and write my 3x plus 2m underneath. I notice that the signs are the same, and when they're the same, we said we subtract. So we get 4x take away 3x, which is x, 2m take away 2m, which cancels out, and we get 10 take away 3, which is 7. That came out neatly. So x equals 7. So we can go and substitute. Now, which one, it doesn't matter which one, you could substitute it into the original one at the very top. You could pick the new one we formed or the 3x plus 2m. So I'm going to substitute it into the old one. Now that was 2x plus m equals 5. So what I get is 2 times 7 plus m equals 5. So 14 plus m equals 5. Oh, that's a terrible 5. 5 minus 14 minus 14. They cancel out. And we're left with m equals minus 9. So m equals minus 9 and x equals 7. Alright? So to recap, what we just covered is, remember the elimination method involves adding or subtracting equations to cancel out one of the variables, the letters. Now if the signs of the variable are the same, you subtract. So that was our 6p plus c and 4p plus c. They had the same sign for c. If the signs of the variable are different, you add them. So in that example, we had plus 3r and minus 3r, so we added those two. Now, sometimes remember you need to multiply one of the equations to make the variables have the same coefficient, that front term. So that was our last example where we had to multiply one of the equations by 2 to get to 2m.